So in this video, we're going to talk about lipid. So the first thing that comes to your mind when we say lipid is this, right? So oil, fat, things that aren't that healthy. If you eat all these things, gonna cause fat, obesity, high blood pressure, so on and so forth. But lipids actually play a lot of important biological functions. So let's talk about the elements that makes lipid. Lipids are organic compounds containing carbon, hydrogen, and oxygen. Examples of lipids are fats, oils, waxes, sterols, some types of vitamins, vitamin A, D, E, K, and also phospholipids. So they are kind of very different from one another. Um, Besides having the commonalities of having a large amount of carbon and hydrogen, the only unifying element for all these type of lipids is really that they're all insoluble in water. A common feature, which is also known as hydrophobic, cannot dissolve in water. So the main biological functions of lipid include energy storage, structural components of cell membrane, and we'll talk more about that later, and signaling molecules, which we'll cover in the later chapter as well. So the types and functions of lipids. So there are a few main types of lipid. The first one is called triglycerides. Tri means three. Glycerides derived from the word glycerol. So main form of triglyceride is the main form of stored energy in living things. Composed of one glycerol and three fatty acid chain. What you see in this picture, that circle is representing a glycerol molecule, and the three squiggly lines is representing the fatty acid chain. The second type of lipid is phospholipid. Phospholipid is the major component of cell membrane with hydrophobic tail and hydrophilic head. Hydrophilic means it's like water, it likes water, so it's able to dissolve in water. So it's made up of two components. The squiggly line, just like triglyceride, is fatty acid. Instead of three fatty acids in triglycerides, it only has two fatty acids. The middle sections over here is glycerol, but the top section over here is actually a phosphate group. So together, this blue part of the phospholipid is actually hydrophilic. It means it's unable to it means it's able to dissolve in water. And fatty acid, because it's fat, is unable to dissolve in water. So that's why fatty acid chain is hydrophobic. The last type of lipid is steroid and wax. So you can see that it doesn't have that fatty acid chain. It's made up of molecules that are unable to dissolve in water. The signature look of it is this four fused rings, right? One, two, three, four. So these four rings stick together. So steroids such as cholesterol, so they're important for cell signaling. And they are the precursor to fat-soluble vitamins and steroid hormones. And we'll talk more about these terms in the later chapter. So as of right now, just remember that the three types of lipids, they all have common thing, which are made of carbon, hydrogen, oxygen. A majority of them are carbon and hydrogen, and they don't really dissolve that well in water. Except parts of phospholipids. All right, the hydrophilic sections can actually dissolve in water. And we'll talk more about them in later chapter. So let's look at a fat, specifically triglycerides. They're constructed from two types of smaller molecules. So we have the glycerol and fatty acids chain. So fatty acid is basically a long chain of hydrocarbon with carboxyl group at the end of it. So you can see that the long chain of it is made up of lots of carbon, and that's why it's not very easy to dissolve fatty acid in water. So in the fat, you need three fatty acids in order to join together with glycerols by a particular type of bond called ester bond or ester linkage. And by joining three fatty acids with one glycerol, you'll be able to form a triglyceride, also known as your fat or oil. And this process is formed through the process of dehydration synthesis, right? You can see that right here. We have a hydroxyl group in fatty acid as well as a hydroxyl group in glycerol. If you take the H from glycerol and an OH from H2O, you'll be able to take out one water molecule and form an ester linkage or ester bond. And you can repeat this process 3 times because a glycerol has 3 hydroxyl groups. And the next thing is you can see that for fatty acids, there are different types of length for fatty acids. And also they vary in terms of the number of double bonds between the carbons. So fatty acid can also be divided into 2 types. So the first type has a maximum number of hydrogen possible, and there's no double bond. We call this fatty acid saturated fatty acid. Saturated means that all of the carbons that you can see in the fatty acids, they only have single bond. There's no double bond for you to add an extra hydrogen inside. So that's why it's called saturated. It's literally filled with all possible hydrogen. Sometimes you will see double bond type of carbon. And when we say double bond, we're paying attention to the double bond between the carbons. So this double bond between carbon and oxygen doesn't count, right? So you can see that all the carbon and carbon, there is really no double bond between the carbons. So therefore, you can see that all of these fatty acids are saturated fatty acids. But sometimes you might occasionally see double bond between the 2 carbon in the fatty acid. So let's say these 2 hydrogens are not here, but if I have a double bond here between the 2 carbons, then there's an unsaturated fatty acid. So unsaturated fatty acids have 1 or more double bond between the carbons. So let's look at saturated fat, right? As we said just now, saturated fats have single bonds. So if we draw a simple skeleton diagram, so each of these turning points represents a carbon. So you can see that there is really no double bond between the 2 carbons. So fats made from saturated fatty acid are what we call saturated fat. And because of the molecular structures those fatty acids are very, very close to one another, right? So the distance between those molecules are just close to one another. So at the atomic level, it's a solid state. So as a result, saturated fatty acid tends to be solid. A common example of a saturated acid is butter. Right? Butter is like a cow fat. So you can see that at room temperature, it's solid state. So most animal fats are saturated. Next, unsaturated fats, for example, olive oil or plant oil or corn oil, they're always in liquid form. One of the reasons is because they have a higher concentration of unsaturated fatty acid. So you can see that right here, we have a double bond between the 2 carbons. So fats made from unsaturated fatty acids are called unsaturated fats or oil and are liquid at room temperature. Part of the reason why they are liquid is because of the band structure of the fatty acid. As a result, if you put all these fat molecules with one another, they space out and are a little bit further away from one another. That makes their atomic level a little bit more fluid, and as a result, they are liquid state. So plant fat and I think I have a typo here. This blank was not supposed to be here, so you can just ignore it. So plant fats are usually unsaturated. So next we're going to talk about phospholipid. So in the phospholipid molecules, two fatty acids and a phosphate group are attached to a glycerol molecule. So you can see in this picture right here, right? So we have the glycerol structure. It is connected to two fatty acids through the process of dehydration synthesis and forming ester linkage right in the middle. Then at the top of it, the third carbon here is attached to a phosphate group. Sometimes a phospholipid will have an additional structure that's attached to the phosphate group. So for example, in this picture, you can see that a choline is attached to the phosphate group, but that's not going to affect the property of this phospholipid bilayer. It's just that you have different variation of phospholipid molecule as well. So in this case, right, the two fatty acids are hydrophobic because, as we said in the previous slide, fatty acids are rich in carbon and hydrogen. They don't have that many hydroxyl group to form bonds with water. So as a result, they are hydrophobic. Sorry, I'm missing a B here. But the phosphate group and its attachment forms a hydrophilic head, so they are able to dissolve in water. So this gives rise to the unique property of phospholipid, and as a result, they are the major components of cell membranes. They basically made out cell membrane. And next, we have steroids. Steroids are lipid structures characterized by a fused hydrocarbon skeleton. And those hydrocarbons are going to fuse together into four rings. For example, cholesterol is a type of steroid. So it's also a major component in animal cell membrane and a precursor from which other steroids are synthesized. However, a high level of cholesterol is also very bad for the blood vessels because cholesterol is going to accumulate within the blood vessels and may contribute to cardiovascular disease, which means heart and blood vessels disease. Some steroids are hormones, for example, growth hormones and then testosterone. They are very important in promoting muscle growth. And these hormones are lipid-based. We have other types of hormones like this that are protein-based, and the differences between these two types of hormones will be discussed in future chapter. So lipids, right? So you can see the lipids is not just making us fat, it also plays a lot of important roles in our body, and you have such a diverse type of lipids. So that's why it's important to eat a certain amount of fat, but you don't want to eat too much of it because it's going to cause cardiovascular disease. So as we said just now, they contribute to lots of important functions for us to survive, such as energy storage. They also form the cell membrane. And they supply energy. Next, so we have different types of fatty acids. One of them is called essential fatty acids. So what it means is that they cannot be produced directly in our body, and it has to be consumed directly from our diet, such as omega-3 and omega-6 fatty acids. So excess dietary lipids can lead to unhealthy weight gain, and increased lipid levels in blood will increase the risk of cardiovascular diseases. So in summary, lipids are organic compounds containing carbon, hydrogen, and oxygens. They're insoluble in water and have essential biological functions. Fatty acids are the building blocks of lipids, categorized as saturated and unsaturated. So saturated fatty acids have straight chains and are mainly found in animals, while unsaturated fatty acids have bent chains and are mostly in plants. Phospholipids are crucial components of cell membranes with hydrophobic tails and hydrophilic head. Triglycerides stores energy in animals, and steroids like cholesterol play important roles in cell membranes and hormone productions. And that's it for today's video, and I will see you in the next video.